Welcome pre-cal students to the homework help video for the assignment that is here in front of you. Let's go ahead and take a look at these problems and see if we can't help you a little bit with your homework. Numbers 1 through 16, the directions state to find a polynomial function of degree 3 using the given 0. So let's start with number 1. If they want us to find a polynomial with degree 3, then we need to have 3 zeros. And we have 3 zeros, so we're good there. So if one of my zeros is x minus 2, I'm going to put x plus 2. If one of my zeros is positive 3, I will put x minus 3. And if one of my zeros is positive 5, I'm going to put x minus 5. Now I'm going to multiply these two these two groups here together, and I will get x squared negative x negative 6. So these two groups have been multiplied together, and now I'm going to multiply my first group times x minus 5, and we will get x cubed minus 5x squared minus x squared plus 5x negative 6x plus 30. And now let's combine our like terms. And then I'm going to check my answer with the book, because these problems definitely lend themselves to little mistakes, and it looks like we got it right. So there we go. We wrote a polynomial function of third degree that has these zeros. All right, let's move on to number 5. Okay, for number 5, if we're going to write a third degree polynomial function, we have to have 3 zeros, and we do. I've taught you that whenever you have conjugates, put them side by side. So my first parentheses will be x minus the square root of 2. My next parentheses will be x plus the square root of 2. And my next parentheses will be x minus 3. Now, when you multiply these two parentheses together, you will get this right here, x squared minus 2. So I've multiplied the first two parentheses together. Next I will bring down my x minus 3. And now let's multiply these together. You will get x cubed minus 3x squared minus 2x plus 6. Now let me quickly check the answer on that to make sure we're right, and it looks like we are. So there we go. There's a third degree function that has these zeros right here. All right, let's take a look at number 9. Okay, now a little more difficult, but not too bad. We have 3 zeros, 1, 2, 3. As I've taught you, if you have conjugates, which we do, put them side by side. So x negative 1 negative 6i times x negative 1 positive 6i, and then x plus 4. Okay, let's multiply our first two parentheses together here. If we do that correctly, we will have x squared minus x plus 6ix. Now we'll take our negative 1 and multiply it through. That would give me a negative x, a positive 1, and a negative 6i. And then we're going to multiply a negative 6i through. That will give me a negative 6ix plus 6i minus 36i squared. Let's go ahead and cross off the terms that cancel out. Your 6ix's cancel out. Your 6i's cancel out. And then this I squared here is really a negative 1. So we're going to end up with a positive 36. So it looks like the simplification looks like this. X squared, cross that off, minus 2x, and then a positive 1 and a positive 36 would be a positive 37. So I multiplied these two groups together, and now I'm going to bring down my x plus 4. And here we go very quickly. Take your x squared and multiply it through. That would be x cubed plus 4 2x squared. Now take your negative 2x and multiply it through. Negative 2x squared, negative 8x. Now take your 37 and multiply it through. 37 times x is 37x, and 37 times 4 would be 28, carry your 2, 148, I believe. Now let's go ahead and combine like terms. X cubed plus 2x squared plus 29x plus, 148. Now let's see if that matches the answer. Let me glance very quickly here. X cubed plus 2x, yes, that is correct. So there, we just wrote a polynomial function of third degree that has these three zeros. Just watch your little mistakes as you do all of your simplifying. Okay, number 13. Find a polynomial function of degree 5, so we know we're going to have 5 zeros, with negative 1 as a zero of multiplicity 3. So I know I'm going to have negative 1 3 times. 0 has a multiplicity of 1, so 0, and 1 has a multiplicity of 1. So there we go. There's my 5 zeros. So my parentheses would be x plus 1, x plus 1, x plus 1, x. Now you can put plus or minus 0, that really doesn't matter. And then x minus 1. Now x plus 0 is just x. So what I'm going to do is I'm going to take this out. And x plus 0 is just x. I'm just going to put an x here at the beginning and not worry about this group. I think that'll be easier. So when I'm all done doing all my multiplication in the end, I'll take an x here and I'll multiply it through. So x plus 1 times x plus 1. Let's bring down my x here. And x plus 1 times x plus 1 would be x squared plus 2x plus 1. X plus 1 times x minus 1 would be x squared minus 1. Okay, now don't let this x here confuse you. We're going to save that for last. Now we're going to take our trinomial times our binomial. And if we do that correctly, here's what we'll get. X squared, take your x squared and multiply it through. That would be x to the 4th minus x squared. Take your 2x and multiply it through. That's going to be 2x cubed minus 2x. And then take your positive 1 and multiply it through. That's going to be positive x squared minus 1. Now I do see some like terms. And that's going to be x to the 4th. And then next would come your x cubed. And then next your x squared, but they actually cancel out. So the next would be your x term, and then negative 1. Now you understand we multiplied this group times this group, and now we have an x on the outside right here. So when you multiply that through, it just raises each power by 1. So we would have x to the 5th plus 2x to the 4th minus 2x squared minus 1. Now let me glance at the answer real quick and make sure we have this right. Yes, we do. So this is a polynomial function of 5th degree that has the zeros that were stated here. Okay, so not too bad. All right, now for numbers 17 and 21, the directions say suppose that a polynomial function of degree 4 has the given zeros. Find the other zeros. Well, here's what we've learned. We've learned that when it comes to polynomial functions, irrational zeros always come in sets of 2, and imaginary zeros always come in sets of 2. So this is rational, so we're not going to worry about it. This is rational, but this 0 here is irrational. So I know for sure that if I have a square root of 3, then also I must have a negative square root of 3, the conjugate. So there we go. That's the missing 0 they wanted you to find. Let's take a look at number 21. 0 is a rational number, so I'm not worried about that. Negative 5 is rational. However, 3i is an imaginary number. So remember, if an imaginary number exists, its conjugate will also exist. So if I have 3i, then in my list of zeros, and of course you can see the answer right here in blue already written, if you're going to have a positive 3i, then you must also have a negative 3i. So there's the missing 0. Okay, moving on to numbers 25, 29, 25 and 29. It says find the other zeros. So once again, we're doing the same thing. This is rational, so I'm not worried about this one. However, square root of 5 is irrational, so I know another 0 we must have is negative square root of 5. Negative 4i is imaginary, so I know another 0 that I must have is a positive 4i. So there's all of your zeros. Okay, let's take a look at number 29. 6 is rational, so I'm not worried about 6. However, 3 plus 4i is an imaginary 0. So then I also know that if I have an imaginary 0, its conjugate must exist. And the conjugate of negative 3 plus 4i is negative 3 minus 4i. Okay? And then here's an irrational 0, and I know if an irrational 0 exists, its conjugate also exists. So if 4 minus square root of 5 is a 0, then also 4 plus square root of 5 is a 0. So there's my 5 zeros. 1, 2, 3, 4, 5. Notice when I wrote the conjugates, you don't change the sign of this first term. Negative 3 stayed negative 3. Positive 4 stayed positive 4. You only change the sign of the imaginary number, and you only change the sign of the radical for your irrational zeros. Okay? All right, let's move on to number 33. Numbers 33, 37, and 41. The directions say find a polynomial function of lowest degree, and they've given us some zeros to use. Now, first of all, you have to go through and always check. There might be some missing zeros. For example, here's a rational number, and I don't care about that. But here's an imaginary number, and I know if 1 plus I exists, then also 1 minus I also exists. So there's the 3 zeros you're going to have to use when you write your polynomial function. Now, let's go ahead and remember, whenever you have conjugates, you put them side by side. So I'm going to put x minus 1 minus I, and then my next parentheses, I'm going to use this 0 right here, and I'm going to put x minus 1 plus I. Now for my other parentheses, it will be x minus 2. Okay, let's go ahead and multiply these first two parentheses together. Take your x and multiply it through. X squared, negative x, positive ix. Now take your negative 1 and multiply it through. That would give you a negative x, a positive 1, and a negative I. Now take your negative I and multiply it through. That's a negative ix, a positive I, and a negative I squared. Now don't forget, a negative I squared is the same thing as a negative 1. Well, if we combine like terms, x squared minus 2x, so cross that off, cross that off, cross that off. Your positive ix and your negative ix cancel. Okay, your negative I and your positive I cancel, so you're left with a positive 1 and a positive 1, and that would give you a positive 2. So when I multiplied this group times this group, I came up with this group right here. And now let's take x squared minus 2x plus 2 times your last parentheses, x minus 2. And if we do that correctly, we will come up with x cubed minus 2x squared minus 2x squared, positive 4x, positive 2x, negative 4. And so we're going to simplify that by combining like terms, and your final answer will be x cubed minus 4x squared, positive 6x minus 4. Okay, now let me check that quickly in the back of the book here. Yes, this answer is correct, so we're going to move on to number 35. Okay, again, you've got to check your imaginary zeros and your irrational zeros to see if there are any zeros missing. 5 is rational, so I'm not worried about that, but 4i is imaginary, so I know if I have a negative 4i, I must also have a positive 4i. And so, in my first parentheses, I'm going to put x plus 4i. In my next parentheses, I will put x minus 4i, and then in my last parentheses, x minus 5. Well, if you multiply your first two parentheses together, you will come up with x squared plus 16, and then you multiply x squared plus 16 times x minus 5, and you'll come up with x cubed minus 5x squared plus 16x minus 80. Okay, and so there's your polynomial function that has the given zeros. Let me check that real quick and make sure that is correct, and it looks like it is. Moving on to number 41. Now, we know if this irrational zero exists, then also its conjugate exists. We know if negative 3i exists, its conjugate also exists. So we have 4 zeros to deal with here, okay? So in my first parentheses, I'm going to put x minus the square root of 5. In my next parentheses, I'm going to put x plus the square root of 5. And then in my next parentheses, x plus 3i. And then in my last parentheses, x minus 3i, okay? And we're going to shrink that just a little to give us a little more space, and we'll slide it up here. And here we go. Alright, now if we multiply our first two parentheses together and do simplifying, you will get x squared minus 5. And if you multiply your last two parentheses together, you will get x squared plus 9. And now let's multiply these two parentheses together. Take your x squared and multiply it through. X to the fourth. Let's see, a negative 45 over here, and I believe a positive 4x squared here. Okay, I will check that in just a second, but that should be what you get when you multiply this group times this group. Okay, so again, what we're trying to learn here is to always make sure your irrational zeros and your imaginary zeros come in sets of 2, and then number 2, you're simplifying process here, making sure that you're not making little mistakes. It looks like we do have it right, so let's go ahead and move on now to number 43. For numbers 43, 45, and 47, they want us to find the other zeros. Now, we could try to factor this first, and I believe it's factorable, but to be honest with you, when they give you one of the zeros like they did, for me, I just very quickly use synthetic division. And it is very fast to do this, probably faster than factoring. And now I know my original problem was a 3rd degree, so I know this is going to be a 2nd degree. So I have 1x squared minus 2. I don't need to put the 0x. So look what I did. I know one of my zeros is negative 5. I already know that. And now all I have to do is find the zeros for this right here. And the zeros for that should be pretty simple. Simply set it equal to 0, bring the 2 over and make it a positive 2. And now take the square root of both sides, positive, negative, square root of 2. So just like that, I have all 3 zeros. By the way, I know that there are no more because remember what we've learned, your degree is 3 for the original problem, and so the maximum number of zeros you can have is 3. Okay? Okay, number 45, they're giving you negative I for one of your zeros, and that's okay. We'll put a negative I here, and let's see if we're missing any terms. 4, 3, 2, one constant term. So we're not missing any terms, so we do not need to put any zeros in. And here we go. Bring down your 1, multiply, you get a negative I. Combine those, and you'll get negative 5, negative I. Now, if we multiply, we're going to get this right here. I would be a positive 5I, and then a positive I squared. But remember, an I squared is a negative 1, so you really have a negative 1 here. So if you combine those, you're going to get 5I. And you know what, students? I just thought of a much faster way to do this, and I apologize for not thinking of this. I just thought of this. I think it'd be a lot faster if we know one of our zeros is negative I. Then we know we have another zero that's going to be a positive I. So I'm going to come down here and start listing out my zeros. They want us to find all the zeros. One zero is negative I. They gave that to me. Another zero has to be positive I. So I'm going to go ahead and multiply these together and watch what happens. I'm going to get x squared minus I squared. Now don't forget, I squared is a negative 1. So I really have x squared minus a negative 1. Well, that's really x squared plus 1. Okay, now think about that. X squared plus 1 should go into this entire expression evenly, and then what I'm left over with hopefully will be pretty easy to finish up. So I think with the synthetic division and all of those imaginary numbers you're going to come out with in the end, it's going to be tough to use those because you're going to have imaginary numbers in your polynomial function, and that's going to be really hard. So I think it's going to be a lot better to very quickly do long division like this, and whatever we're left with up here, we'll then factor that. It should come out even. We should get a remainder of 0 because this should divide evenly into this, because I got this expression right here that I'm circling from my two zeros down here, and we know both of those zeros have to exist. As long as I've not made any mistakes so far. So here we go. Divide first term into first term. That's going to be x squared. Go ahead and multiply. That would be x to the 4th positive x squared. Let's go ahead and subtract. These would cancel. You'd be left with negative 5x cubed. 7 minus 1 would be positive 6x squared. Bring down your negative 5x and your positive 6. Divide first term into first term, and that's going to give you a negative 5x. Negative 5x times x squared is negative 5x cubed, and negative 5x times 1 would be negative 5x. Subtract, these cancel, subtract, these cancel, leaving you with 6x squared, positive 6. X squared goes into 6x squared 6 times. 6 times x squared is 6x squared. 6 times 1 is 6. Subtract, and all of these cancel. 6 minus 6 is 0. 6 minus 6 is 0. So we have taken this big polynomial function, and we have broken it down to this right here. So now that's all that I have to factor to find my remainder zeros. I already know the zeros from this expression are right down here. Now all that I have to do is find the zeros from this expression right here, and I think this is factorable, excuse me, and it should be pretty easy. What two numbers multiplied together give me a positive 6? When added together give me a negative 5. Well, a negative 3 times a negative 2 is a positive 6, and if you combine those you get a negative 5. So it looks like your other zeros will be positive 3, positive 2. So there we go. We did it. Positive 3, positive 2. Pretty good problem, by the way. Pretty good challenging problem. Okay? Alright, moving on very quickly to the last problem on the homework assignment, and we're finally just about finished. Okay, number 47. They're telling us 4 is one of the zeros, so I'm going to put a 4 right here. We're not missing any terms, so my coefficients would be 1, negative 6, 13, and negative 20. Okay, bring your 1 down. Now multiply 4, combine negative 2, multiply negative 8, combine, it's a 5, and 4 times 5 would be 20. which would give you a 0. So far we know our zeros are 4 because they gave that to us, and now we know our original problem was a third degree, so we know these numbers right here that I'm circling are going to be 1 less, a second degree, so x squared minus 2x positive 5. Now you cannot factor that, so unfortunately what we're going to have to do is we're going to have to use the quadratic formula on this to get our last zeros, okay? So here we go. Negative b, well, b's already a negative 2, so negative 2 is a positive 2. Positive negative the square root of b squared, well, if you square negative 2 you get 4, and then minus 4ac. Well, 1 times 5 is 5. All over 2a. A is 1, 2 times 1 is 2. Okay, let's continue and simplify under the radical. We would have a negative 20 and 4, that would be a negative 16 all over 2. So we're going to make this negative 16 positive and put an I right here. And now we'll continue right up here to positive negative 4i all over 2. And now, of course, we can reduce each term by 2. 2 goes into 2, 2 goes into 2, 2 goes into 4, and we're left with 1 positive negative 2i all over 1, or in other words, just 1 plus minus 2i. So there's your 3 zeros. One of your 0 would be a positive 4, and the other would be 1 plus 2i, and the other one 1 minus 2i. Okay, I hope this homework help video has been a help to you. Call or email if you have any questions.